Hello, and welcome to this fifth part of Patents for Entrepreneurs. So the subject today will be patent mining. So essentially how to get those trade secrets and patentable ideas out of your teams, out of your development process. And this is something that took me quite a while to figure out myself. And I've developed a method that I've used with over 100 companies now. And I think it's working really well. And the feedback that I get from companies that have been through the process is that it's a game changer to be able to extract ideas from your team. And I hope that you will think the same thing after watching. So as always, my name is Ola Wassvik. I'm the CCO and co-founder of Lightbringer. But in my previous life, I was a deep tech CTO. Have a bunch of patents and have mined many patents ideas. The disclaimer, as usual, this is not legal advice. This is business advice. This is how you should run your business and how to extract the ideas from your business. You still need legal counsel when it comes to IP and patents because everything and every field is slightly different. But let's start. So this is about how to convert solved problems into defensible IP. And you're going to hear me talk a lot about problems today, not as much about solutions. And I think this is one of the major changes to making an effective patent mining is going problem first and then classify the solutions. Finally, you choose what to patent or not. So I will go through this stepwise. In the end, I will show you a typical process that you can implement in your company. And if you still feel that you need help, I'll be happy to assist you with patent mining. We have it both with humans, but also AI can heavily assist in doing excellent patent mining. So the core idea is that every solved problem creates IP. And this is very important to baseline. It's not that every single solution that you do necessarily creates IP. It's the problems you solve, because a lot of the solutions will not have actual problems. They will just be a part of doing business. So the first thing you need to do is to identify the problem. And quite often people think that identifying IP is something you do with a handful of engineers. That's not the case at all. The entire company should be involved. And you will see this, that based on what level you're at, you will have different types of people who knows the problem statements and can be part of it. Then you will have a solution to it. And that quite often may come from the development team or the engineers. Then, once you've identified those solutions to the problems, then you have trade secrets. Not all trade secrets should be patented, and quite often, less than half of your trade secrets should be patented. So just because you discovered something in a patent mining session doesn't mean that it should be patented. It just means that it's a trade secret that is a patent candidate, and that you can then decide if it's suitable for patenting or not. So the golden rule of patent mining is don't ask, what can we patent? That question is absolutely forbidden. What you ask is, what problems did we solve that others still struggle with? That's how you get to the real innovations. So the workflow is quite simple. You start by logging all the problems, and you do this with different people in the room depending on what type of trade secret and patent you're identifying. You likely will have to run multiple sessions, and it's also something that's not a one-off. You do it typically at the start of a project, sometime in the middle, and before you go public, to make sure that you get out all of the IP that is needed. And trade secrets are equally important as patents, because if you don't know what your trade secrets are, there's a high risk that someone in the team will disclose them to someone who shouldn't know about it. So logging your trade secrets is as important as logging your patents and patentable ideas. So you log the problem, and then you say, okay, what was actually hard about this in our environment? Because one of the very common problems is people say, well, this isn't new. Someone did it in some other industry. That doesn't matter. The problem will be different in your industry, and you can take solutions from other industries and solve problems in your industry, and it will be relevant. Then you capture that solution. How did you actually solve the problem? And then you classify it. It's also important to understand what type of trade secret or patentable idea this is. Is it on the conceptual level? Is it on the product? Is it on the system or inside the product as a component? And finally, you decide the visibility. Will someone be able to see this? Because that's how you classify if it's needed to be patented or not. And things that can't be seen shouldn't be patented. So this is all about operational discipline. You do this in a structured way, and this is a process. And if you have people who are good at processes in your company, this is typically the person that you put that on. This can be a product manager. This can be some kind of administrator. It's usually not the shoot from the hip CTO who just wants to get stuff done, because then you do it once and you don't do it again. So try to put this operational discipline on someone who is actually disciplined within your company. So always start with a problem. So let's take a very weak prompt going into a mining session. What did we invent? Because the first thing that happens when someone says, what did we invent? Is that it's only the people who think they invented something who will answer the question. And usually it's the same handful of engineers who knows what an invention is. And you miss all of the inventions from the people who don't actually know what an invention is. So if you instead prompt them by saying, what problems did we solve, for whom, and why was it hard? You will get a lot more answers about what problems you solved. And you ask things like, what problems did we solve for our customer? What problems did we solve for our integrators? What problems did we solve for the end user? There are many problems, and you should try to identify them all. This will actually also be good for your sales process, because by knowing which problems you solved, you will be able to sell to the next customer. So let's start on the highest level, the conceptual patents. And here is an interesting thing. I typically never do conceptual patent mining with the engineering teams, because this is more about whoever is customer facing. This can be in the supply chain. This can be with the external interfaces you have. And conceptual patents have a very high business impact. You can essentially cover an entire business segment by filing a conceptual patent. But you always need to then anchor it in a technical effect and a technical solution. But a great question for mining a conceptual patent is, what problem did we solve for the ecosystem? What made people adopt this product? What is our unique selling point? And you can understand now why you need the customer facing, the business people in this type of mining session. It's still probably an engineer somewhere down in the organization who actually had the solution, but they will have a very difficult time identifying the problem. And if you get good outputs from this, you will have solution architectures, you will have workflows, you will have control schemes, high-level things that cover a very large business segment. Moving on to the next one, which is actually where most people first go when they think about patents. They think about the product, and the product is super important. You should do this on the product level. And here you bring in product engineering. You bring in the design, you bring in the manufacturing team, but you also bring in whoever is testing and quality checking, and the operation teams. Because one of the most common way of getting a great patent is to make a very cheap and effective product. And typically, the design team doesn't know that, the operation team does. So this is highly tied to the product, and it's quite often very powerful because it's easy to see evidence if a competitor is actually copying what you're doing. So product patents are very important, but they typically don't cover the entire business, and you will need to do them for multiple products, and you might have to do several for a single product. So then you ask the question, What problems had to be solved for this specific product to exist? What did we do that actually made it work and made it possible to manufacture and get out to the customer? And here, if you get good result, you will have product level protection where you have the architecture, how the components are mounted together, all the external and internal interfaces. Then we move on to a type of patent that is too often overlooked and is very, very powerful. These are system patents. This is how you protect your ecosystem, how you basically stop others from working with your ecosystem, how you lock in your ecosystem to work with you. And you most often see these in how does your ecosystem integrate with your product. So here, you may not have the design team. Here you have the integration team, you have the platform team, you have the ecosystem partnership. Again, you will bring in business-facing people because they're the ones who know how people are actually integrating versus your product. And the typical question here is, what did we do to make this product work with others? And what did we do to make it work better than just our individual products alone? And great outputs here is essentially patents that cover how you interoperate with others, how you exchange data, how you make features that were not possible from using your product alone. Finally, on the deepest level here, we have the component patents. This is typically where your engineers wants to start. So it's important to understand that engineers typically bias heavily towards component patents, and they are very strong if you get them right. You can reuse them for multiple products. You can really show that the competitor is infringing by saying, hey, they're using exactly the same component that we are. And it's a great source of getting real portfolio depth and real powerful patents that you can use in a courtroom at a later date. And here, you typically have the core technology team. You have the system architects, but you also try to get in the manufacturing platform engineering teams that actually had to make these things work together. And the question here is that inside this product we built, what did we do that we can reuse for something else? That's a component, something that can stand on its own legs and be reused in another product and also make that product powerful. And here you have internal mechanism, you have reusable modules, you have subcomponents, you might have a thermal feature, you might have a calibration hardware that works better. So this again is where engineers tend to bias heavily towards, and they are important, but you need to see them in the context of all the other layers as well if you're intending to build a strong. So then comes the question, should I patent this or keep it secret? And here you do a reverse engineering test. You basically check if this product was on the market or if this component was on the market, how would I figure out how it works? And the decision test that I always use to check if I should keep it as a trade secret or to patent it is if someone else were to spend 1,000 hours, like a team of 10 spending 100 hours each, and $1 million. And again, this is important that we come to next. How big is your market? So $1 million can be a small sum when it comes to taking a market that is $100 million or $1 billion big. But $1 million, if you're protecting $1 million market, yeah, then you can kind of see where this is going. You probably shouldn't have many patents if your market is that small. But as an example, you've developed a semiconductor chip. It's cost less than $1 million and 1,000 hours to do a reverse engineering of exactly how it works. So you need to protect it. But you shouldn't include things where they would need access to your source code or your manufacturing line to get this information. So assume that they don't have access to your manufacturing line, they don't have access to your source code. Could they still, by spending 1,000 hours and $1 million, figure out how it worked? For most firmware algorithms, that answer will be no. It will take longer than that to get it done. And then it should be kept secret instead of patenting. And the 4 choices you have is, of course, you can patent or you can keep trade secret. But you have 2 other buckets as well. You have the maybe later bucket. You basically keep it in and see, okay, it's difficult to discover and the business value isn't that big. Let's keep it trade secret for now, but let's reevaluate as we go along. And then we have the kind of strategic patents. It's possible, but they won't immediately discover it, but it might have high legal value. So for example, if the market is large, yes, then you patent. If the market is small, then you don't. So it's very important to not patent everything. And it's very important, typically, not to trade secret everything. There's a balance in between the two. And doing these kind of tests and putting them in different buckets is a good way of determining if you should be patenting or not. So coming into that portfolio mix, I typically am a proponent for the 50-50 mix. If you're a company where patents are important, you identify 10 trade secrets through these mining methods that we've gone through. You keep 5 secret and you patent 5. But it might bias towards either end. If you have a physical or very visible product that someone can just disassemble and look at, then you should probably have more than 50% of the trade secret as patents. If you're in a software-heavy product, lots of algorithms, many things that can only be seen if they would have access to the source code, you should have a lot less than 50% patents for all your trade secrets. So make sure that you figure out, is my product in a very visible or a very non-visible segment? Finally, the thing that can also significantly pump up the number of patents you need is if you need to license. So example, if you would need to license your manufacturing method, all of those trade secrets that require them to go into the manufacturing line, well, they will actually go into the manufacturing line because you will tell them how to manufacture it, and then you need to patent those as well. Same thing if you need to release some of your source code to your customers. So then you just, on a licensing perspective, you look at it similarly. What are the things that I have to expose? And all of those things now need to be patentable so that someone just can't come and copy the product and not license our technology. And very important here, it's not only about will they license or not, it's about what price leverage do you have in negotiating a license fee. Because if you have a weak license portfolio, your license revenue will be smaller than if you have a strong licensing portfolio. You can ask ARM about how this works. They are the experts on licensing and keeping their margins up. So take a look at their portfolio if you want to see some master art on how to design a good licensing portfolio. Then you prioritize by business value. There are basically 2 axes. It's the need for protection, and that comes with the visibility or how much time you spent on it. But don't forget the market size, because even if you have a high need for protection, if you have a small market size, you have a heavy risk of overspending. You can't spend too much if your market size isn't big enough. And then on the other end, even if you have some things that you might not immediately patent, if you have a very large market, there's the risk of underprotecting your large market, because as soon as people identify that large market, they will try to go after it. If you have low value, low visibility, you probably should keep them in the trade secret bucket as long as possible. The only thing you have to think about there is your own freedom to operate. This, again, is why it's super important to log your trade secrets, because if you've logged a trade secret and you now have the product on the market, if someone else comes and says, I have a patent for this, then you can say, sorry, this was already in the product that we released 5 years ago. So logging your trade secrets is very important if you decide not to patent them. Then, if you have a high need for protection and a large market size, that's when you invest aggressively in patents. To recap what you should be doing here and make this a clear operating routine, You review any solved problems at every milestone. And this is why I'm saying you can't just do it one time, because most of the valuable IP will be discovered during the development process and the integration with customers and solving all the bugs that you find out when you go to market. Then you capture why each problem was hard. All the simple things you should capture as well, but the hard ones or the non-obvious ones are the one that are most likely to have patenting a capability. You sort them in the conceptual product, system, and component bucket, because you don't want everything in the same bucket. You want to cover all the abstraction layers, and you also want to cover all of your technology fields. Then you apply. You have all your trade secrets. Now you apply the 1,000-hour $1 million rule. And then you can see, okay, the ones that did not pass that rule, that someone will be able to discover by spending 1,000 hours and $1 million, those are now up for patenting. But you still have business value, visibility, and budget to consider. So if your budget is not low enough, you then prioritize from most important business value to lowest. Most companies will have a limited patent portfolio. It's typically only the very large enterprise companies that have an unlimited budget and limitation on innovations. Your company will very likely not have a limitation on innovations and have a limitation on budget. So you need to prioritize business value. The ones that then fit into your budget and are most suitable for patenting, you patent, and all of the others you keep trade secret, and you make it clear that they are trade secrets so that your entire team knows what not to talk about, to not accidentally disclose IP. Okay. So thank you very much for attending this webinar. And if you have any further questions, feel free to reach out. And if you need help with patent mining and getting this process started, also reach out. I can help you out with that.